Hello and welcome to this video on how to run a confirmatory factor analysis for free in the Jamovi software. My name is Geiser. I'm an instructor and statistical consultant with QuantFish. In this video, I want to show you how you can run a confirmatory factor analysis at no cost by using the free Jamovi software that you can download directly from the internet. As you can see, I already have Jamovi open here on my computer, and so the first thing that I can do is I can open a data file. And the nice thing about Jamovi is that you can open SPSS data files directly. So you can click here on this icon open, and you can see that here I have my math.sav SPSS data file that I'm going to use for this illustration. So you click on that, and then this file is being opened by Jamovi. You can see your variables here on the left hand side. You can scroll all the way through to make sure all your variables are there. Notice that there's some missing data here in this data file, and this can be handled in the confirmatory factor analysis in Jamovi very appropriately by using full information maximum likelihood estimation, thereby including all cases that have at least partial data. Where do we find the confirmatory factor analysis option in Jamovi? You click on factor, and you can see that there are different options, including principal component analysis, exploratory factor analysis, and the last one is confirmatory factor analysis. So we click on that, and then the input window on the left hand side is very straightforward and intuitive. You can see that you can define your factors here. Factor 1 is the first one that will be defined, and so you can pick from your variable list in the same way as you would do that, for example, in SPSS for an analysis of for example, variance or regression analysis or exploratory factor analysis in SPSS. So it's very easy to use. And so I'm going to pick 3 variables for my first factor. Those are 3 variables that pertain to a cognitive abilities test. So those go on factor 1. You can see you can change the factor label. The default label here is factor 1. I could just call this cognitive. And then I know this is my cognitive factor. You can see on the right hand side, output is already being generated. So even though I'm not done defining my confirmatory factor analysis model, you can see I already get the estimates for that single factor model. This model is identified with 3 indicators. It's just identified or saturated, which means it doesn't have positive degrees of freedom. You can see that from the model fit table here, where the DF are given as 0. So this model is just identified, which means you can get parameter estimates here, the loadings and standard errors and Z statistics. However, this model cannot be looked at in terms of model fit, or the model fit here wouldn't be relevant, but that's okay because we're not done yet with the model anyway. We want to define a second factor, and this is very easy to do by clicking on add new factor on the left hand side. This is then by default called factor 2. Now, my second factor here that I want to specify is going to be a math ability factor. So I'm going to call this factor math. And then I'm going to drag 3 variables from a math scale, so subtests from a math scale over to the math factor. And you can see the output on the right hand side is then being adjusted. So now we have the 2 factors here. Now you can also see the model is over identified with 8 degrees of freedom, because now we have a lot more variables in the model, and the variables have a simple structure, a strict simple structure where they load only onto 1 factor and none of the cross loadings are allowed. So this model has a whole bunch of degrees of freedom, and so those are given here. Now notice that in the output, the default setting here is that the factor variances are standardized to a variance of 1. You can see that from the factor estimates table, where cognitive is 1, so that's the variance of the cognitive factor, and also math is 1, so that's the variance of the math factor, and Jamovi tells you that's a fixed parameter. So the default setting in Jamovi is that the model is identified by fixing factor variances to 1 and estimating all factor loadings. And you can see that here all the factor loadings are being estimated freely. They all have a standard error, they all have a z-statistic and a p-value. Furthermore, Jamovi estimates by default the covariance between the factors. In this case, cognitive with math is 0.85. And since the factors have been standardized to a variance of 1, this covariance of 0.85 can be interpreted as a correlation. So those two factors are correlated 0.85, which is a very strong correlation, showing that cognitive abilities in this sample were strongly related to math achievement. Those were very highly correlated at the latent level. Also, one thing that we should check first, obviously, is the model fit, and this is given in the test of exact fit table. There's a chi-square statistic of 11.7. That chi-square statistic has 8 degrees of freedom and a p-value of 0.163, which is not significant at the 0.05 level, indicating that the model fits the data well. It does not have to be rejected, or we can say there's no significant discrepancy between the model estimated or model implied covariance matrix and the observed covariance matrix. So this model does not have to be rejected. Also, you can see that closeness of fit indices or approximate fit indices also look good for this model. The CFI is 0.996, the TLI is 0.993, so they're both very close to 1. The RMSEA is 0.03 about, which is also a good value for RMSEA, and so this model looks good, so we can interpret the parameter estimates. Now, you can get additional output in Jamovi, and so one thing that we might want to look at are standardized loadings. Right now, we're only getting the unstandardized loading, so that would be one thing, and then maybe there are some other things that also we would be interested in. So first, here under residual covariances, you could define covariances between error terms for certain indicators, which is not generally recommended unless you have a really good reason to do so. So we're going to leave that alone since our model fits well without correlated errors, and so we don't want to add anything here. Under options, you can then see that the model is being estimated by using full information maximum likelihood estimation with missing data, and that's what you typically want. So you don't want to use listwise deletion because you would lose cases and you would make more restrictive assumptions about the missing data mechanism than you would with full information maximum likelihood. So that's a good thing that Jamovi uses full information maximum likelihood and includes all available data. Also, you can see under this option, you can change the constraints that identify the model. The default is, as I said previously, that the factor variances are fixed to 1, and you can change that to a scale option where the first indicator on each factor has a loading that is fixed to 1. So when I click on that, you can see the output changes again, and now the first loading on the cognitive factor of the KFT verbal indicator is fixed to 1, and the other loadings change accordingly. And then also the math indicator number 1 here is also now fixed, or the loading of that indicator is fixed to 1, and the other loadings are then changing accordingly. And also the factor variances are changing because now they are no longer fixed. So now we have a free factor variance here for the cognitive factor of 34.19 and a free variance of the math factor also, which here is 2.1. So that's up to you. That's an arbitrary choice in most cases, whether you identify the model by fixing the variances or by fixing one loading per factor. It doesn't change the model fit. You can see our chi-square is still 11.7 with 8 degrees of freedom and a p-value of 0.163, so that doesn't change anything there. Also, it doesn't change the standardized solution, which we haven't seen yet. but we can find it under estimates. When we click on estimates, you can see that we can request the standardized estimates here by clicking on standardized estimate, and then another column is added to our parameter estimates tables, where you can see that now the standardized factor loadings are given for all indicators. They look pretty decent, all around 0.75-ish, more or less. And then also we get the standardized covariance, again 0.85. That's the correlation between the two factors. Now, the estimate here is no longer the correlation, because the factor variances here are no longer standardized in the unstandardized estimate column. So therefore the 7.2 is the factor covariance, and the correlation is now given here under standardized estimate. Also, you can get confidence intervals if you like, and you can take a look at other parameters such as residual covariances. In this case, we have only residual variances, so those are the covariances of the errors with themselves. So this table then with the residual estimates would give you only residual variances or error variances, which may be important for you to report when you produce a report of this model. So you might want to include those. Also, under model fit, you can request additional fit statistics, such as, for example, the SRMR, the standardized root mean square residual, which may be interesting in addition to the other ones. If you select that, then you can find it under your model fit measures table. 0.0184 is the SRMR, which also looks very good. It's very small, so indicating that there are no substantial residuals here in this case. When we click on additional output, you can take a look at the residual correlation matrix. So that's another way to look at model fit or model misfit. When we click on that, we get the residuals for the observed correlation matrix, meaning those values that show us to which extent the observed correlations can be reproduced by the model. And you can see that those are all close to zero, indicating that the model does a good job reproducing the observed correlations in our data. So there's not much left over. And that, again, indicates that the model does a good job here, fits the data well. This residual correlation matrix is what is summarized by the SRMR. So that's an overall measure of the standardized residuals. And so that basically echoes what we see here in the matrix, with lots of values that are close to zero, as it should be. You can also request modification indices, which offer another way to look at model misfit and also potential ways to improve the model fit. You can see these modification indices here are provided for different parameter estimates. In this case, the first matrix shows which cross-loadings may lead to an improvement in fit. And so all values of modification indices that are greater than 3 are highlighted in red here, because those could be indicating something that's more important. There's one that is 6.015 here, and that's for the cross-loading of the quantitative scale for the cognitive ability test on the math factor. And that kind of makes sense, that the quantitative scale that has numeric content on the cognitive abilities test, that's more strongly associated with the math factor than are the other subscales. So this cross-loading kind of makes sense. I would still not add it here, because overall the model fit is so good that I don't see a need to change the model in any way. Also, there's an indication of a potential residual covariance between the figural and the verbal subscale on the cognitive abilities test. This is also a modification index that is relatively high, but again, I wouldn't add that covariance here, because the model fit overall is excellent. So no need here to change anything. But it's useful that Jamovi offers you these types of diagnostics so that you can assess model misfit in more detail. You can also generate a path diagram of your model, which may be nice to look at. So when you click on plots, path diagram, then Jamovi generates a path diagram of your confirmatory factor analysis model that looks like this. And so it's a relatively nice picture. You can verify that that's the model that you actually wanted to specify. I hope you found this video useful to learn about how to run a confirmatory factor analysis for free in the Jamovi software. If you did, please subscribe to this channel. Check out the description for additional resources, including workshops that I teach for QuantFish, and I'll see you next time.